Thank you for showing up to this particular talk, and if I'm not mistaken, I am standing between you and recess. Is that correct? Yeah, so I'll try to be quick. I just set the timer there. Hello everyone, my name is Joyce. I'm the head of developer relations at Postman, an API platform used by 20 million devs. This is my first time at Cascadia. Can I get a show of hands? Who has used Postman before? Oh God, these lights are bright. Okay, amazing. All right, so I have worked at Postman for the last 5 years. I've been rolling around in APIs for a really long time. Well, 5 years is a long time. For enough time, and so I decided to give a talk about reverse engineering a private API. Who has ever tried to do this? Leave your hand up if you were successful. Okay, I'll be asking you guys for help. So we're going to be talking about why reverse engineer APIs at all. And then we'll get our hands dirty. We will capture network traffic, individual requests, session data, as well as start streaming network traffic into a proxy. And then we can capture it and inspect all we want, but we want to be able to replay the API calls when we want to. So we'll take a look at some scenarios like cookie-based off. I won't talk about SSL cert because Eddie just talked about that. And then we'll talk about spoofing client attributes and learning how to replay it in your own bot script, whatever you want to replay in. All right, so reverse engineering, if you're not familiar with it, is also called back engineering. It's the process by which a man-made object is deconstructed to reveal what's going on inside. But if you don't have access to the object or the thing that you're trying to take apart, then you might be reverse engineering it. So another word, here's a synonym used to describe reverse engineering, is also called hacking. And hacking has a little bit of an iffy connotation, but Alyssa Knight, she calls herself a reformed API hacker, says all hacking is figuring out how something works. Sending a stimulus to an application that the developer that built the application, did not anticipate. For the rest of us, why would we reverse engineer an API? Why do it? Okay, so here's some examples. This hit Hacker News a while back, but somebody hacked Papa John's API. They wanted extra bacon and duplicate item. You couldn't, they actually client-side validated duplicate items. However, duplicate item as a property on the bacon object was not validated. So somebody's able to get extra bacon. Here's another example. This person wrote about it, huge fan of couch surfing. This is Airbnb before Airbnb was a thing. You can stay on other people's couches. Lived in the French Riviera, really popular couch, and was flooded with all these requests. He wanted a calendar and a filter. He wanted custom functionality, and when he reached out to the couch surfing people, they said, unfortunately, we're not gonna make an API for you to do this kind of stuff. They wanted to control what you could do with their back end. Another example, Starbucks. How many people like Starbucks? And like, you know what's possible with APIs, but does the Starbucks team? Sorry if anybody here is from Starbucks, but there's selfish reasons that you want to be able to reverse engineer an API for. Okay, now we're getting into like the seedier side of reverse engineering. This is a subreddit specifically for defeating cheat detection. Okay, how many people have looked up cheat codes? This is reverse engineering games. And here's another one, cheating at life. So if anyone's ever done online like app dating, you have to use your eyes, you have to look at the person, you have to read, decide if you like or dislike somebody. It's super tedious, super manual. What if you could just script that? You want to filter for somebody that has cat gifs and then take an action. I don't know which way is the action, but you want to be able to script that. So you can see the date on here. Tinder has definitely covered up that vulnerability, but there's always reasons why you're like, oh, I wish I could reverse engineer that. And this is one I wrote. This is probably not the crowd for it, but if anyone's ever tried to go camping at Yosemite, there's good camping spots and like less good camping spots. And they've changed the way they do it now, but they used to announce, okay, camping spots are open, and within 60 seconds, all those camping spots are booked. How can that be? I physically can't click through their interface. Well, they have a web API. So I figured out a way to book a campsite in Yosemite Valley by reverse engineering APIs. Okay, sorry if that inflamed anybody here. I know this is probably not the crowd for it. Okay, so lots of reasons to reverse engineer an API. Maybe you're an API consumer. Okay, the engineering team is really slow. They're not building the features that you want. Maybe you want to build your own custom app bot or entire application. Or maybe you just have selfish reasons that you want to reverse engineer an API. So that's for API consumers. For an API producer, there's legitimate reasons too that you might do this as part of your work. So if you are a security engineer or a quality engineer, you probably are good and have a good mindset for reverse engineering. And you can use it to diagnose and debug issues. You can use it to do penetration testing and performance testing. Okay. So if you're an API consumer, I'm guessing the majority of us here are API consumers that want to learn a little bit more about reverse engineering. Here is my legal disclaimer here. When you're reverse engineering an API that's not yours, review the terms of service. You can get sued, banned, or issued a cease and desist, whatever. But if you publicly share the code, you can have criminal liability too. So here's the rule of thumb. Responsible disclosure. If you find a vulnerability, you always want to report it to the company first and let them have an opportunity to patch that first. And an opportunity can be immediately, it can be a year. It's quite subjective, and if you're curious about this, the Electronic Frontier Foundation's Coders' Rights Project is a good resource to look into. And TLDR, she said something about legal disclaimer, criminal disclaimer. Be ethical on a case-by-case basis. Consider the broader stakeholders. So that Yosemite example I told you about, I'm kind of proud of it, but I'm kind of not, because people get really, really angry about that kind of thing. And was I cheating at life because I beat somebody, I knew something about APIs and now I'm advantaged? Okay, so be ethical. All right, let's get to getting our hands dirty. Capturing network traffic. The first thing we'll take a look at is visibility of API requests. We'll use Chrome DevTools, curl requests, and okay, let's hope this works, because I recorded all of this, so all my tokens could be expired by the time y'all see this. Okay, so is it working? Nice. Okay, so here I am on TikTok.com. And I'm scrolling, I'm opening up Chrome DevTools, and here's all the network calls that are coming through. Most of us have probably seen this, but the first time I saw this, my mind was just blown. How does a website work? So these are all the different network calls you can filter by method, status code, and if you right-click on it, you can copy it as, it went a little fast, but you can copy it as curl and import it into Postman as text. So this is what that curl command looks like. You can be in terminal, or you can bring it into a graphical user interface. And then the graphical user interface will divvy everything out by parameter. So there's a lot of stuff that goes into this one API call for TikTok. And some of it we can see. Some of it, the keys are very clearly written. TikTok has a couple that are very obscured where it's just single letter properties. And then we can send our call, replay it, and inspect the response that comes back. Okay, so you can always copy an API call as curl and import it into whatever your favorite tool is as raw text. I don't know, how do I, okay, there we go. Okay, so when I right-clicked on copy as curl, there's actually a lot of different formats that you can copy it as. So that's a single API request. Let's expand our search to session details, an entire session. And so one of the options there was har files. And you can also use curl to capture an entire session. But now we'll take a look at HTTP archive format har files, extension har. There's probably a joke here somewhere, but I didn't think enough about pirates. OK, so let's take a look at saving all as har. We are still browsing TikTok, and now when we copy, we're saving all as har with content, and now we're going to save it as a file, a local file. And don't take a look at my local files. let me describe to you with words what would be happening here. Have you failed me, Google Slides? Oh, this actually looks really cool on the video too. Let me describe to you with words, unfortunately. So you can import that HAR file, and what you'll see is a collection that has bazillions of however many API calls that are being made in the back end. Well, that's unfortunate. Okay, let's go on to the next one.
You're importing into Postman here?
Yes, you're importing the HAR file into Postman. And you can, remember, you can use curl. You saw all those copy as formats, so you can use your favorite format. Curl can be either an individual API call or session, and HAR is typically used for session replay. What if none of them work again? Okay. Oh, good. I have a, well, no, I didn't get that screenshot. Okay, so this is save content as HAR file. So we took a look at an API, individual API call. We took a look at a session. But now let's start streaming all the API requests. And we can inspect traffic coming from client apps like web browser. We were just looking at TikTok.com. Mobile apps, we can look at TikTok app. And any kind of connected devices. So we're going to be using a web proxy. It's a server, and I think the image is a little bit more clear than the text, but it's a proxy server, a substitute server that sits in between the client application. In the picture, it's a mobile app or a mobile device. So the web proxy is going to intercept the traffic going on its way to the website server. Okay, so we're using web browser, but any HTTP client app, like a mobile app, I did a live stream where I hacked my Roomba. As long as you're on the same local network, you should be able to web proxy your network calls. And again, I'll show you using Postman, but there's a lot of free tools that are very, very popular. There's a ton more than this, but you have man-in-the-middle proxy, Fiddler, Burp. All of these have some free version of a web proxy that you can use. So let's use Postman. Okay, so I'm in the Chrome browser. I installed an extension called Postman Interceptor. And when I turn on the proxy, you can see all, okay, so none of these are on TikTok. I don't know if you can see that well, but those are all the, just back end, all the Chrome windows that I have open. When I apply filters, I can actually filter by TikTok.com or subdomains. And as you scroll, you'll see those AJAX calls. Filtering in the back end. Okay. So that's using browser extensions. Let's click through. That's a screenshot, so you can see the various post and get calls. All right, so that's a flood of calls just coming in through your extension. How do you snap one of those up? Let's proxy that into a Postman collection, and a collection is just a group of your API calls. If you had seen the HAR file import, you would have seen how that looks. So here I am on the left side, I have my interceptor on the Chrome browser. On the right side, I'll just create a new collection to contain all of my network calls. And I'm on the desktop app, slightly different. It's not Chrome catching from Chrome. And then at the very bottom, you can capture requests. I'm zoomed in real hard, so having trouble there. And then I'm already connected. You see it on the left side. And now I can filter, proxy them all into this collection. Hopefully you'll get to see what that looks like, since you didn't see the HAR. Okay, so on the right is going to be all the API calls that are coming in. And now I'm back in Chrome. I'm browsing. Oh, this looks interesting. What's this? Okay, so a lot of get calls, a lot of post calls. And then it's actually really hard to see here because it's piling up at the bottom, but if you can see the number of requests, 21, 22, 23, 24, that's the number of back-end calls that are hitting TikTok servers. 37, 38. I'm narrating in case people can't see the number. Okay, so let's stop our session. That was a really short session. And then now you have your get calls and your post calls. Snap that picture in your mind for a second. Does anyone know why TikTok.com has so many post calls? Yeah, so whoever said that over there, I think that's probably true. I took a peek at some of those post calls, and it's a ton of metadata. Your operating system, your device, your battery life, just all sorts of information. Your position that you're like scrolling from. There's a lot of data that's being sent to TikTok servers. Okay. Okay, so this is just a screenshot, just in case that went a little fast. All we did was proxy, our client in this case was Chrome browser, and we proxied those web calls over to Postman and saved them in a collection so that we could replay them and poke it, update all the parameters and poke at it. Okay, let's take a look. I keep losing my cursor because I have a screenshot of a cursor. Okay, so we talked about different types of apps. For mobile apps are exactly the same. So here I have a screenshot of, I'm on Android, so all you need to do is check if your proxy, in this case we're using Postman on a local machine, a MacBook, we're looking up our IP address and then pointing our mobile device to that same IP address. We're on the same local network, we're pointing it to the same IP address and port. And all of that traffic information will come through from your mobile app. It's pretty neat if you've never sniffed data before. Okay. So we looked at an individual API request, a broader session, and then we looked at a stream of API requests so that you can go multi-domain and multi-session, multi-device. You can aggregate all of that information. And I've actually done that before to document a poorly documented API. So if you don't have documentation, if your engineers don't have something that you can go look at, you can load up the website, set up the proxy, start clicking around. Click on the profile, add a comment, edit a comment, and look at all those web APIs that the engineers are using on the back end. All right. Now it's time to replay. So one of the toughest things when you're reverse engineering API is you saw me intercept or copy as curl a single API call. And then I hit send, and it worked immediately. It was like magic. But anybody, those 4 people that had their hand held up, know if you want to hit send again and you wait an hour or you wait a day or you wait a week, it's probably not going to work, right? So there's certain access tokens that might expire or time out. Let's talk about a couple different scenarios. The first one is cookie-based auth. Okay, so for cookie-based auth, when a user enters in their auth information, their credentials, into a browser, the browser will send it over to the servers. The server is going to return a cookie, log that session ID, and then send it back to the browser. The browser is going to keep that cookie until you clear your cookies, folks. And then the browser and the server can have this conversation that records the same session ID. Okay, so let's take a look at how to do that manually first. Okay, so I'm going to hit github.com. And there's a tab called cookies. The cookies are what's being sent back from the GitHub servers. And when I preview what github.com looks like, you can see I'm not signed in. So I can manually add my cookies by domain and start syncing. So what I'm syncing with right now is the Chrome browser, and I'm logged in on Chrome, so now when I hit that call again, I have a bazillion more cookies, and it went a little quick, but under the response body, you saw I was logged in. So it's syncing your cookies from your Chrome session to Postman, and if you take a look, man, that went really fast, but I don't know how to pause it. If you take a look at what was in the console, github.com sent back a ton of cookies. And then one of those response headers is going to be set cookie. That's going to be the cookie that you include in all of your requests going forward for cookie-based auth. Okay. Yeah, and I don't know how to make it not play again either. Okay, so here's a screenshot. Fortunately, I don't think I'm revealing any personal information here, but here's the cookies that you would then set for your other requests. Cookies coming back from the server. Okay. All right, and then one of the things that I think is difficult, because I answer a lot of Stack Overflow questions, I answer a lot of forum questions, and I always get, it works in Postman, but it doesn't work in my app. Sometimes I think tools are so good at abstracting what the problem is and helping you get that success, that 200 OK or whatever success code you're looking for, but it abstracts it so much that you're not able to see exactly what's happening. So on the right side, you can see here is the actual API call that's, oh gosh, it's in curl, but you can choose whatever language or framework you're looking for. So you can see exactly how to format that API call so that it works. And then I think I have a screenshot of it later, but also just take a look at the raw request and raw response that's coming back. Sometimes like the syntax highlighting like futzes me up, and so I think just being able to look at the raw and the pretty version is helpful. All right, so let's talk about spoofing client attributes. Let's pretend to be something that we're not so that we can fool the servers. So we'll be taking a look at user agent header to access things like dynamic websites. So dynamic websites are based on code that's rendered. So in the old-timey days, the server rendered everything and then sent it over. And now they're relying on the client to render a lot of this code. So if I just put in github.com or linkedin.com, wait, we don't like LinkedIn here? If I just put in one of those dynamic websites and I inspect the HTML elements, I expand, a lot of the stuff isn't going to be there the way you see in a browser. And so how do we spoof it? I actually came upon this because I was trying to scrape Postman data, and I couldn't, and the API didn't give me what I wanted. So I don't think I have a video here. Actually, did anyone not see that? Does anybody know what I should do? Did everyone see that? What should I do for user agent? Any hypotheses? How can I see dynamically rendered data? You saw it. Okay, if you didn't see it, kudos to you, because that was like mind-blowing. So when you send, there's two rows I want you to look at in the screenshot. The first one is the checked, well, they're both checked. The top user agent that has the strike through it. Whenever you send a call through Postman, Postman automatically creates these headers, these temporary headers, and says, hey, it's coming from Postman, I'm over here. You can override that by adding another user agent, Googlebot. And the reason why this works for Postman.com, like a lot of sites, does anyone know why? Googlebot? Everyone wants to be scraped by Google, right? So for SEO equity, Postman will currently render all the code, render all the content about once a week so that it can get scraped. So if I am sending something to Postman.com and I update my user agent, I can then expand all those HTML elements and actually find the data that I would see in a Chrome browser. Okay, so you never know what the server will accept back, so it can't hurt to just try. Okay, so the very last point I want to make here is, I kind of already said it, but it's totally fine to replay something in your favorite Postman or graphical user interface or whatever you're using, but a lot of times you want to then roll it into code, into a script, into a bot, into an integration. And so I already showed you that image of the code snippet that you can generate. And I don't have it here, but also just look at the console. Almost every tool you use will have a console, so you can take a look at the raw data that's being sent. Okay, so key takeaways. We talked about why reverse engineer an API. It's going to be different if you're an API consumer or an API producer, but there's legitimate reasons for both, and there's kind of illegitimate reasons for both too. And we took a look at dev tools, curl, har files, web proxies, lots of different types of tools. And the reason why there's so many different formats and so many tools you might be using, we looked at a Chrome extension too. There's so many different use cases, and every API is going to be different. So the 4 people that had their hand up that successfully reverse engineered a private API, I think it takes a lot of the puzzle solving mindset, one that I don't have, right? If I didn't want to go camping, I never would have just banged my head against an API for so long. But if you have that kind of intuition and hypothesis in your head, I bet, well, I made an API once like this. You don't know how they're validating stuff on the tail end, and you don't have a lot of visibility. But that's the reverse engineering part. So the last thing I'll close with is do not violate your terms and conditions. Always be ethical. Be excellent to each other. And then I will just end with something that Eddie had such a great talk, and I feel so smart after watching Eddie's talk. I want to end with something that'll make you feel smart too. So hacking, the definition of it is sending a stimulus to the application that the developer that made the application did not anticipate. Okay? So Hiram's law, this is a Google engineer, Hiram Wright, and he said at scale, anything you offer through an API can and will be used by someone out there. Even if you didn't intend for them to update that bacon object, somebody's going to find that out and come to rely on it. So here's a relevant XKCD that illustrates Hiram's law. I'll just read it out loud. So somebody's releasing changes to version 10. The CPU no longer overheats when you hold down spacebar. And longtime user complains, this update broke my workflow. My control key is hard to reach, so I hold spacebar instead. And I configured Emacs to interpret a rapid temperature rise as control. And that's just their workflow, man. You gotta know that you're gonna be breaking a flow and other people are gonna try to tap into undocumented aspects of your API. And that's all I have. Thank you very much for your time. I'm so sorry, 30 seconds, 30 seconds. I do have a bobblehead here, so the first person to find me in real life, and I have a second one, the first person to find Kate in Gather online, so people watching at home, the first person to say how you can order extra bacon at Papa John's correctly gets a bobblehead. That's it. Yay!